Well, hello everybody, it's me Aashish Dahal, and today we'll be going to talk about laws of indices from grade 10. So first of all, what do laws of indices mean? Indices means your power or an order of an expression. If you take a simple algebraic expressions, you will have three types of expressions, or let's say three components in an algebraic expression. So this is an example of very basic algebraic expression, that is 2x to the power 4. So this 2 is called a coefficient. You can write coefficient. X is your base. X is called base, and your 4 is the power. So what will you do when you have to operate on indices? So for that we will have to look at the laws of indices. So let us start with. So to make it easy to operate on our indices, we have a set of laws. So first of all, let's talk about the product law. And first thing to remember when doing all of the indices exercises, you need to have same base if you want to simplify it. If you don't have the same base, then your indices cannot be simplified. Like if your base is x in an expression, so x to the power 4 into y to the power 4, you cannot operate it because base is different. One is x and another is y. But if you have x instead of y here, x to the power 3, so x, it is the same base. So according to the product law, whenever you have same base and multiplication or product sign in between, you can add your indices. 4 plus 3 equals x power 7. So here let's look at the product law. In the example there is given, whenever you have a to the power m into a to the power n, where a is not equal to 0, because if a is 0 you cannot operate it. We cannot operate anything on 0. So a to the power n m into a to the power n becomes a to the power m plus n. So basically understand that whenever you have a product sign in between and you have your same base, indices will be added. So second is your division law. So division law is the exact opposite of product law. Whenever you have a division sign in between of two same bases with indices, then you will have to subtract the indices. So let's see here, x to the power a upon x to the power b. It has same base xx and it is in division form, so we can operate on indices. In numerator it will be positive, but when the indices from where the power from denominator comes to numerator, it will become negative. So a is a positive but b is negative. You will get your a minus b. So whenever you have something like x to the power a minus b, you can break it down on x to the power a upon x to the power b. This is just the division law. Okay, another law is your power law. So what happens when you have two powers, like x to the power 4 whole power 3. So when you have power upon power, you just basically multiply it. 4 times 3 equals x to the power 12. Well, laws of indices is a relatively easy chapter from compulsory mathematics. So we can just see here distributive law. A upon b whole to the power m will be distributed to a to the power m upon b to the power m. Or if you have a into b whole power m, then you can write a to the power m into b to the power m. So let's move on to the next law, which is our inverse property law. So what happens when you have indices in negative? So it basically means take the whole expression down on denominator, 1 upon x or x to the power 1, it doesn't matter. So whenever you have x to the power minus 1 kind of expression, you can do 1 upon x. It is also the same as division law, because here a to the power n is changed into a to the power negative of n when going to the numerator side from the denominator. So if you have let's take another example of this inverse property law. If you have x to the power a minus b, so you can write it like x to the power a, you have negative sign, so take it down on denominator, x to the power b. So when it is in denominator, it has a positive sign, but when the term or indices from denominator comes to numerator side, it will be subtracted. Are we good till here? So I think you are right. Okay, so next is your root law. So first of all, before starting the root law, let's know what the order of the root means. So I think you are familiar with this root sign. It equals 2. So it is your square root. So square root basically means upon how many repetitions can you take 1 out. So if you just further simplify it, square root 4 is 2 times 2, and here is order of root 2. We just basically don't write the 2 in the square root. So it means whenever you have 2 set of identical numbers, you can just take 2 out from 1. So when you have 2 set of identical numbers, you can take only 1 out. So it is 2. So if there was cube root is denoted by your number 3 in your root. So this is called order of the root. It determines from how many characters or from how many set of identical numbers you can take 1 out of the square root. So let's see, not 9, let's take 27. If you break it down, then it will be 27 means 3 times 3 times 3. 3 is a 9, 9 is a 27. So your order of the root is 3. So from the identical set of 3 numbers, you can only take 1 out. So it is basically your order of the root. So let's move on to our law, root law. So root law states that whenever you have a power in a root, x to the power 4, suppose it will get in division, x to the power 4 upon order of the root, which is 2 in this case. If there was 3 cube root, you will have to write 4 by 3 here. This is basically the same. Okay, so and last but not the least, zero property rule. Suppose you have x to the power 0, it will automatically be valued at 1. So if you have 100 to the power 0, it will also be valued to 1. Even if you have 10 lakhs power 0, it will also equal to 1. Okay, it's just a figurative description. Okay, so let's go on to some exercises and solve some short questions. So we have what we have here is a typical question from the laws of indices. So here you will have to use product rule. So the question is 2 to the power x plus 2. As we know in the product rule, whenever there is plus you can just break it down into multiplication sign taking the two bases. So 2 to the power x plus 2 gives 2x into 2 to the power 2 plus 2x plus 1 gives 2 to the power x into 2 to the power 1 whole upon 2 to the power x plus 1 gives 2 to the power x plus into 2 to the power 1. So and 2 power x is here. So I think you are familiar with the basic idea of taking common. So we have a 2 to the power x, we are going to take one common, and write down what the remaining is left. So here you are left with 2 power 2, and 2 power 2 is here, and you will have 2 power 1 in the second expression. So you can just write 2 only, because power 1 basically means 2. So same as the numerator, in the denominator we can take a 2 to the power x as common, and 2 to the power 1 means 2 plus 2 to the power x is gone, so we only have 1. So be careful that whenever you have only a single term and it gets common out, then you will have your 1 here, not 0, because 1 multiplied by 2 power x is 2 power x. So basically you cannot change the question. So here 2 power x get cancelled. So 2 to the 2 square x equals 4 plus 2 whole upon 2 plus 1 equals 3. 6 by 2, your answer is 3. So it is one of the relatively easy chapters from compulsory mathematics. So let's go to another example. So let's move on to another example. Here I have a little bit sophisticated question, but it is easy nonetheless. So what you have here in the question is 1 upon 1 plus x to the power a minus b, and 1 upon 1 plus x to the power b minus a. So using the division rule in x to the power a minus b, we can write like 1 upon 1 plus x to the power a upon x to the power b. So negative b when turned to denominator will become positive. So in the same process here we get x to the power b upon x to the power a. You can write here. So I have just given a note if you, in case you forget the formula, which formula are you going to use. So x upon x to the power a upon x to the power b results in x to the power a minus b. So what next to do here? So basically it is taking x to the power b as LCM in the first expression. We have x to the power b here, and if you do not have anything, then you can use the denominator 1, and LCM of x to the power b and 1 is x to the power b, and 1 into x to the power b means x to the power b plus x to the power a whole upon x to the power b, plus same method x to the power a plus x to the power b upon x to the power a. So next step is we are going to use the simple rule of a by b whole upon c by d. So it is in the case of a means 1 upon 1 whole upon xb plus xa upon x to the power b. So it gets in the format of a upon b whole upon c upon d. So we can write like a by b into d by c. So using the same process, we have x to the power b in the numerator, x to the power b upon x to the power a plus x to the power b, plus xa in the numerator, so xa upon x to the power a plus x to the power b. If you are confused till here, please don't hesitate to ask me anything. So next up, what we are going to do is x to the power a plus x to the power b and x to the power a plus x to the power b. So we don't need to take the LCM as they are like terms here. So you can write it like upon x to the power a plus x to the power b, or upon, and in the numerator side you can write x to the power a plus x to the power b. So it basically gets cancel out, and whenever you are cancelling in the form of multiplication or division, your answer will always be 1. and if we are calculating on x to the power a minus x to the power a, in case of plus minus you will have 0. So don't get confused whenever you have a division sign or negative sign. So thank you very much, and in next class we are going to do more sophisticated problems, and please be sure to follow me. Thank you very much.